Theorem 2.2. Let L be the language accepted by a non-deterministic finite acceptor Mn equal to Qn summation delta n Q naught Fn. Then there exists a deterministic finite acceptor Md equal to Qd summation delta d sequence Q naught Fd such that L equal to L of Md. Proof. Given Mn, we use the procedure NFA to DFA below to construct the transition graph GD for MD. To understand the construction, remember that GD has to have certain properties. Every vertex must have exactly mode summation outgoing edges, each labeled with a different element of summation. During the construction, some of the edges may be missing, but the procedure continues until they are all there. Procedure NFA to DFA. NFA DFA ആവുന്ന procedure ആണ്. First step ചെയ്യേണ്ടതെന്ന് വെച്ചാൽ create a graph GD with the vertex sequence Q0. Identify this vertex as the initial vertex. 2. Repeat the following steps until no more edges are missing. Take any vertex Q1, Q2, etc. Qk of GD that has no outgoing edges for some A belongs to summation. Compute delta star n of Qi A, delta star n of Qj, A, etc. delta star n of Qk or A. If delta star n of Qi, A union delta star n of Qj, A union etc. union delta star n of Qk, A, which is equal to sequence Q1, Qm etc. Qn. Create a vertex for GD labeled sequence Q1, Qm etc. Qn if it does not already exist. Add to GD an edge from Qi, Qj etc. Qk to Ql, Qm etc. Qn and label it with A. The third step, every state of GD whose label contains any QF belongs to Fn is identified as a final vertex. Fourth step, if Mn accepts delta, the vertex sequence Q0 in GD is also made a final vertex. Next, finite automata. It clears that this procedure always terminates. The construction stops after a finite number of steps because each step adds a new edge to the GD. The GD can have at most 2 raised to mod Qn mod summation edges, so the process must eventually stop. We use induction on the length of the input string. Base case, for string of length 1, the GD correctly represents the Mn transition. Inductive step, assume it is true for string of length less than or equal to n. For a string W equal to Va, if the Mn moves from Q0 to Qi on V and from Qi to Qt on A, then the GD moves from Q0 to a state containing Qt. Hence the GD correctly simultates the Mn for all strings. Next, example 2.13. Convert the NFA in figure A into an equivalent deterministic machine, since delta n of q0 0 equal to sequence q0 q1, we introduce the state sequence q0 q1 in GD and add an edge labeled 0 between q0 sequence q0 and sequence q0 q1. In the same way, considering delta n of q0 1 equal to sequence q1, give us the new state sequence q1 and an edge labeled between q0. There are now a number of missing edges, so we continue using the construction of above theorem, theorem 2.2. Looking at the state sequence q0 q1, we see that there is no outgoing edge labeled 0. So we compute delta n of q0 0 union delta star n of q1 0 is equal to sequence q0 q1 q2. This gives us the new state sequence q0 q1 q2 and the transition delta d of sequence q0 q1 comma 0 equal to sequence q0 q1 q2. Then the figure A, using A equal to 1, I equal to 0, J is equal to 1 and K equal to 2. Delta star n of q0 1 union delta star n of q1 1 union delta star n of q2 1 equal to sequence q1 q2. Make it necessary to introduce yet another state sequence q1 q2. At this point, we have partially constructed automaton shown in figure B. Since there are still some missing edges, we continue until we obtain the complete solution in figure C. Figure B and figure C.